In tonight's video, guys, we wanna connect all these batteries here, and I will monitor all the BMSs live on the screen, put them next to each other so we can compare exactly what is happening while charging and discharging. I'm just kidding, guys. I promise you, no screen sharing today. Tonight we want to work with this beautiful item. Guys, welcome back to another video here from the Off-Grid Garage in Late Night Show, Australia. I don't know, it is already 9 and I'm starting a new project. So tonight is a lot of do-it-yourself work. We want to work with the SEPLOS Polo batteries here and want to get rid of this rat's nest. Look at all these cables here, that's disgusting. And when I introduced the SEPLOS Polo batteries to you a couple of days ago, I said there might be space for a bus bar running all the way down across all 3 terminals and connecting these batteries in a wonderful and beautiful way. Because so far, SEPLOS has just advised to use ring lux cables and make your own connections between these batteries. Yeah, and while this is something we could actually do, I'm not a super big fan of such short links. And then here in the middle battery, they would sit on top of each other. I guess it kind of worked, but since I said this in the video, I was actually chasing this bus bar idea. Well, and just yesterday, this wonderful and beautiful Aluminium Bus Bar has arrived here in the Off-Grid Garage. It is a 20 by 20 millimeter bus bar. Stupidly enough, I didn't go with the 16 by 16 millimeter bus bar, while this gap here is exactly 18 millimeters. And of course there's an online bus bar calculator where you can enter the dimensions of your bus bar and it gives you the result for copper, aluminium, iron, GI bus bar, whatever that is, and silver. 20 by 20 gives us 320 amps for an aluminium bus bar. And now you can say, well, Andy, if the gap is only 18 millimeters, you have to take 1 millimeter away from each side of the bus bar. Otherwise, it doesn't fit in between. So in theory, we have only an 18 by 20 millimeter bus bar. 18, calculate, which still gives us 288 amps for aluminium. So the formula for the ampacity of these bus bars is very simple. It is the area times 0.8 for aluminium or times 1.2 for copper. That's all. And we know the version 3 of the SEPLOS BMSs are set to 80 amps per battery. So 3 times 80 is 240. And here we have 288 amps still. So we should be good, right? Still annoying because I could have gone with a 16 by 16. Which gives us 204.8 amps for aluminium. Would have still been sufficient for this battery. 200 amps gives us 10 kilowatt, just coming from this battery. But now we have to make this 20 by 20 bus bar work. I want to have a look how long this actually is. Oh, I think we are just 1 millimeter too short. That is... Yeah, it is 1 millimeter too short. Oh well, I will leave some feedback on eBay accordingly. So the first step, obviously, is to cut this one in half. Exactly there. Because this is such a nice and beautiful aluminium bar. I really don't want to put this in the vise like this, so we need some... Well, I need some sort of rack or something. I'm very sorry, Average Joe, but this is the only option we have at the moment. I'm really glad you sent 2. Okay, let's cut this bastard in half. Just taking these edges off a bit. Yeah, I slipped with the saw. Damn it. So now we've got our 2 bus bars, positive, negative. Or maybe this one is the positive and this is the negative. I can't remember. All breakers are off. So the bar would basically go from the bottom of this terminal across this one to here, and then it stops just over there. There is another part from SEPLOS which goes on top of this battery tower. It is an inverter. It has the same shape, the same dimensions as one of these modules, but they are not available yet. Once they come out, I will test them, we put this together, and hopefully it will actually fit our bus bar then. And these accessories, these are little metal brackets which go across these two holes, and they are holding the modules together like this. See? There's a slight problem. You probably can see it already. The holes are not lining up. And they are not lining up here. They are not lining over here, neither down here, neither down here on this side. They actually only fit up here when we connect the top module to the lid, to the roof. See there? That is, it just fits here. Just. But, well. Anyway, we just keep going. So this would be our bottom bus bar. So I need to go up until there. Next one up is from here to here. And the top one. So let's see if we can narrow this down a bit and can take 1 millimeter away on each side. So it actually fits in between our terminal. So it is just 1 millimeter from the top and 1 millimeter from the bottom, and then we have 18 millimeters left in between. I found a really quick way now to make these cutouts here. So first I do 2 cuts with the hacksaw. So I've got my boundaries. And then I use this really aggressive round file. So this takes away a lot of material. I then work on both sides and holding the file on an angle. And then I keep working on the middle part. With a flat file I can perfectly work out this edge. I filed a bit over the corner here. Sorry. Okay, let's give it a first fit. Bottom. Fits, middle. Oh, look at this. We've got a bit of play. It fits. It looks good. I should have gone with a 16 by 16. All right, you have a good night's sleep. See you tomorrow morning. Where have you been? Where have you been, guys? I thought we are doing this bus bar thingy together as a team, so to speak. Well, now it's finished. Took me 5 to 6 hours or so to finalize the 2 bus bars. Filing aluminium is not fun. Total bastard material. So, here they are. I've got 3 notches per bus bar, which exactly fit into the terminals now. So here, look at this. I've got a tiny bit of play, which is nice. And here on negative, slides in nicely. I also managed to put in these links here, these brackets, whatever you want to call them, to keep the modules together and secure them. But I had to drill up one of the holes because they were not lining up for some reason. I have sent this issue to SEPLOS Quality Control already. So the only thing we need to do now is drill the holes for our bus bar connections in the right spot. Then from the top of this screw, there, to the top of the next one, which is exactly, and there's really not much contact area here on this terminal. It basically goes only until here, because this part here on the right is already bended backwards. You can hardly see it, eh? There, now you can see it. I should have gone with a 16mm bus bar, not with a 20mm. It would have saved me 5 or 6 hours of filing and cutting and... This is all the material which I have filed out of the aluminium bus bar. This is all. This is everything. That's all. Isn't that crazy? Took me 5 hours. So let's see how straight this was. Oh, pretty good. Pretty good. It's right in the middle. I still haven't got a benchtop drill press here. There's no space. I haven't got space for that. Beautiful. Straight in. .174 precisely. If I drill straight. Okay, first one. And will this one fit? Ooh, it's a bit tight. Nah, goes in. Yeah, goes in. Nice. Okay, one to go. So let's see if we fit. Bottom, come on. It's a tiny, it's a tiny, which direction? I can't even tell. If I look into the hole, I can't even tell in which direction it needs to go. Nah, it's totally fine. Perfect. Positive done. One to go. Negative bus bar. Fits a bit hard, but fits. Oh no, this one doesn't. Oh no, it goes so smooth. Oh wow. Fits. Look at this. That looks actually pretty cool. So the only thing missing is the 8mm hole at the top here, where we can connect our cables then back to the main bus bar of our Powerwall 2.0 or whatever. The heat shrink is a bit large for this 20x20 bus bar. So we've got some bubbles here and some wrinkles, which I don't like. So I may take this off again and buy suitable heat shrink, but for the moment it's good. It gives you the idea. So I'm cleaning up these contact areas here with alcohol for peace of mind. I'm not going to use any grease or conductive paste or something. So I repeat, I'm not going to use any paste or grease underneath here. This bus bar goes directly on the battery terminals as it is. I just clean this up a little bit, that's all. Because since I'm not using any grease or paste anymore, I have no trouble with any connections between bus bars and terminals of batteries anymore in the battery shelf, nothing. So the initial problems could have been caused by the polishing of the terminals, which I did. What? What did you do? I didn't hear anything. And I had really massive trouble with battery number 1 at the beginning, right? And then we used the Paul's Magic Aluminium Bus Bars, and it was pretty much gone. And I've never used any paste or grease. I've got 2 different conductive greases here, which I'm not going to use anymore. At this stage, I'm not sure what to do with the top part here. Once there's a cable connected, it's blank, unisolated, potentially dangerous. Any ideas? Okay, so at the moment all the breakers are off, of course, so there's nothing in parallel. And we can turn them on one after another and then see how much current goes from one battery into another battery. They should be all fairly equal because the voltage is almost the same. All right, let's plug in our communication cables. And then we connect this battery to the computer and have a look what's going on. But this will be after dinner.
Much later.
Alright, the last video clips you just saw are over a week old now. So I went to dinner and never came back to the garage. The next day I got really sick. And I haven't been in the garage here for over a week now. But I'm feeling slightly recovered now. 80%, good enough to start making videos again. So welcome back after a week. We have 110 amps outside. Yeah, I said a week, not a month. This is just 1 week ago and we've got over 100 amps outside. Still in the last month of winter. Crazy. Okay, so we want to continue. We wanna. So, and I have already established our communication between all our batteries here. Starting here from the top with port number 2, RS485 number 2. Goes to RS485 number 1 on the next battery. And then number 2 again goes to number 1 of your last battery. And the RS485 communication cable to your computer goes into the port number 1 here at the top battery. And this is also our master. Any BMS communication cable would need to go here in the top one. And we don't need any dip switches, of course, because this is all automatically set now. And if we have a look at the documentation of this BMS, we can also see that these RS485 ports are not the same. So let's click on start. Nothing will happen here, of course. Nah, because we need to change this one here into parallel mode. There we go. And automatically we can see, hopefully. No? No habla? You know what happened? Because I wasn't in the garage for a while here, they went to sleep. Only the top one is flashing and the bottom one is flashing, but the one in between is not. So there's no communication between the top one and the bottom one if this one is off. That's actually an interesting factor. Okay, let's turn this middle one on. Yep, it looks a lot better. And here's our pack number 2 and pack number 1. As you can see, I had a bit of a play with these batteries here. Oh, this one is only on 7% here. 77 and 25% only. Okay. Well, this is what we have, right? Okay, I would say without further ado, let's connect the circuit breaker for pack number 1. All right, pack number 1 is live. There's nothing we can see. Of course not. Nothing else is connected. Now, I have actually disconnected the positive here, which goes back to our power wall over there, because I'm charging the Mason battery boxes at the moment. So we will have a look at this situation later. And once we hit this breaker, we have battery number 1 and 2 in parallel, and we should have a current going through the bus bars. Well, and this is a 77% and a 25% battery in parallel. Voltage is 1.3 volt difference. That'll be fine. Okay, let's turn this one on here. And we should see some current flowing now. noise. Of course, this one gets discharged here and this one gets charged. We can see the current here. It's almost nothing. Okay, let's introduce battery number 3 as well. Yep, it's on. What can we see here? Here it goes. So battery number 3 is now being charged from battery number 2 and also battery number 1. 52.05, 52.1 and 52. See, the voltage is almost the same, and look at the difference in state of charge. If this is not crazy, good old lithium iron phosphate batteries. Same voltage, state of charge, so much difference. So, and this will basically now continue until the voltages have equalized. And I guess we will still have around 25 or even 30% state of charge difference. Same voltage, no current flowing anymore. Oh, I've just seen battery number 1 has stopped discharging. So it's all coming from battery number 2 into battery number 3 at the moment, 15 amps. And basically that's all. That's all we can see here by connecting all these batteries in parallel. And the rest, it will figure it out automatically once we fully charge this whole tower. But we will have a look at this in one of the next videos. This was here mainly the idea to have these batteries connected with a bus bar instead of cables. So while it was a lot of work to file down these bus bars here, it looks actually pretty nice and neat. Oh, have you seen my loincloth here? I was thinking of how can I cover these terminals here, because they are exposed now and I don't like this. And I came up with this one here. So you can actually lift this one up. Look at this. There's your screw. And then you put your loincloth back on. Is that good? I don't know. If you have any other ideas how to cover these bus bar terminals, these areas here, let me know in the comments. Yeah, and also for this top part here, how do we cover this stuff? I don't like these being exposed here. Alright guys, I think so far this video from today, or the last couple of days, the last couple of weeks almost. Yeah, I thought I'd share this idea with the bus bars here on the channel, so you can actually see how it looks like and how it works. It's a pretty nice and clean installation. I like it. But again, a 16 by 16 millimeter bus bar would have been super sufficient for this. I got a bit carried away by the 20 by 20. As always guys, thank you so much for watching. Thanks for... Oh, I need to sit this way here. As always guys, thank you so much for watching. Thanks for all your great support here on the channel. All these wonderful and beautiful people who have donated to the channel. Thanks for buying me a beer. And until the next video guys, you stay charged, stay safe, and thanks again for watching. See you then. Bye bye. You little perverts. Oh shit. Shows t-shirt. I guess it's as good as new. It's almost new. It'll be fine. It'll be fine. It's a bit itchy now. Oh shit. Oh wow. Sorry.